Okay, so today we're going to multiply and divide. And first we're going to start with multiplying. So the biggest thing to think about, and that some errors that I see, are signs. So we have same signs equals positive, different signs equals negative. So we have 3 times 5, 15, pretty simple. And then negative 3 times negative 5. Remember, when we multiply two negatives together, it becomes a positive. Same sign, positive, so this is also 15. Oh, my lid. Okay, different signs, negative. So 3 times negative 5 is negative 15. And negative 3 times 5 is negative 15. Alright, rational numbers, so fractions or decimals. 7.4 times negative 2.5. Well, we know right away that it should be negative because there's different signs. And we can really use our calculator for this. So I would recommend using your graphing calculator, but I don't have one on me at the moment, so I'm just going to do it with my phone. And you can always multiply the numbers together and then add the negative side at the end. Rational numbers, so remember multiplying, so this is a vocab term. Multiplying fractions, right? And when we multiply fractions, we multiply the top. So 2 times 3. We multiply the bottom, 5 times 4. We have the negative there, and then we simplify. So we always want to simplify. So this will turn into negative 3/10. Something else you can do when you're multiplying is you can cross cancel. So if we look here, we have negative 2 over 5 times 3 over 4. We can simplify this, the 2 over 4, to 1 over 2, and then multiply across. We get negative 3 over 10. So essentially, in this one, we're simplifying at the end, and when we cross cancel, we can do the simplification beforehand. Okay, when we have a rational number with an integer, we have to remember integers are always rationals, right? 4 is the same thing as 4 over 1. So we could do negative 4 over 5 times 4 over 1, and then we just multiply our fractions across. Negative 16 over 5. Remember, when I give you a fraction, you want to give me back a fraction, and we always want improper fractions, not mixed fractions, right? So or mixed numbers, right? So right here, this is a mixed number. We don't want a mixed number. So let's turn it into an improper fraction. So we have 1 times 4. 4 plus 3, so negative 7 over 4 times negative 4 over 3. Same sign, so it becomes positive. We have 28 over 12, and that simplifies to 14 over 6. Simplify again, 7 over 3. Or we could do the cross multiplying thing again. We see these 4's cancel, and then we're just left with negative 7 over negative 3, which is 7 over 3. Okay, let's do another problem that I'll give you. Let's make this one absolute value of 3 times negative 8. So remember, absolute value is a grouping sign, so we have to do everything inside of it first and then take the absolute value. So 3 times negative 8 is negative 24. Then we do the absolute value around it, and it becomes 24. And then finally, we have a radical, another vocab term. Anything with a root. 3 times 12, keep it in the radical, 36. And then we can take the square root, and that equals 6. Okay. I just wanted to be clear about something. So if we look over here, when we see a fraction with a negative, right, let's say negative 1/2, this is the same thing as negative 1/2 and 1/-2. These are all the same thing. Sort of like that meme with the 3 Spider-Mans pointing at each other. So it's just the way that you like to write it. I would say this one and this one is more common, but it doesn't really matter where the negative sign is, because if you put it in your calculator, it would always be the same thing. Like if I did negative parentheses 1 divided by 2, I'd get negative 0.5. If I put negative 1 divided by 2 in my calculator, I get negative 0.5. And if I put 1 divided by parentheses negative 2, or just negative 2, I would get negative 0.5. So it's all the same. I would show you in the graphing calculator if I had it, but I do not. Okay, similar to the commutative property of addition, we have the commutative property of multiplication. So, trying to fit this in view of the camera. Okay, so we have A times B equals B times A. Let's test it with some numbers. 2 times 4 equals 4 times 2. This is 8. 8. That works. And we could do, it doesn't have to be numbers, right? We could also do x's. Like let's say 4 times x, that equals x times 4. The standard way of writing this, though, would be the coefficient in front of the variable. And the associative property of multiplication, same thing. A, B, C equals A times the quantity B of C. So if we did numbers again, 2 times 4 times 3 equals 2 times the quantity of 4 times 3. Let's see if it works. We have to do order of operations, parentheses first. 8 times 3 equals 2 times 12. 24 equals 24. Right, and that would be the same if we use variables. We could do x times 3 times x equals x times the quantity of 3x. Those would both end up being 3x squared. So just like addition, there's commutative properties and associative properties of multiplication. Commutative property is just switching it. Associative property is switching the grouping symbols. Alright, and divide. So people don't like dividing sometimes because it reminds them of fractions. But we're going to have to get used to fractions. Okay, so simple 8 divided by 2, we know that's 4. Right, it's the same thing. Same sign, positive, different sign, negative. Okay, 8 divided by negative 2 is negative 4. Well, I guess this should go, right? This is that one, and this one's this one, and this one. Alright, negative 8 divided by 2. If you remember up here, right, we said that these are all the same thing. So, when we're looking at this, it's the same thing as negative 4. Right? It's like negative 8 divided by 2. And then finally, negative 8 divided by negative 2, same sign, so we're going to have positive 4. So a lot of you guys aren't simplifying this. We need to get it to this. Or like, you wouldn't want to see negative 4 over negative 1, or negative 3 over negative 4, right? You take out those negative signs. If it's the same sign, it becomes a positive. Alright, let's take a look at dividing rational numbers. So 12.4 divided by negative 3.5. We should use a calculator for this one. And again, I prefer it on the graphing calculator, but all I have is my phone. So 12.4 divided by 3.5. And then I'm just going to put the negative on at the end, because there's not a good negative button on here. 3.543. It's always a good idea to round to 3 decimal places. That's a pretty safe bet. Okay, negative 2 over 9 divided by 4 over 9. So this is a vocab, dividing fractions. So when you're dividing fractions, you need to multiply by the reciprocal. So if we were to write this over here, right, it'd be like negative 2 over 9 all over 4 over 9, right? So the shortcut is over here. We do negative 2 over 9 times 9 over 4 equals negative 18 over 36, and that simplifies to negative 1/2. And remember, we could cross multiply. Negative 2 over 4 turns into negative 1/2. So we're multiplying by the reciprocal. So multiply by reciprocal. Remember, reciprocal means you just flip the numbers. Another vocab term. The reason why that works is, let's say we wrote it like this, right? Negative 2 over 9 over 4 over 9. So we don't want a fraction over another fraction, so we're going to actually do the identity property of 1 and times 9 over 9, right? And so this would make that one cancel out, this would make that cancel out, and then we get negative 2 over 4, negative 1/2. So this is essentially taking a shortcut. You just want to multiply by the reciprocal. But there may be instances like this where we write it all big and try and get rid of the denominators. But if that confused you, just make sure you look up the dividing fractions vocab and you know how to do it. Alright, and then we have another one. Negative 3 over 5 divided by negative 2 over 3. So we know it's going to be positive because it's same sign. So we're going to do 3 over 5 times 3 over 2. We did the reciprocal, took away the negatives, we get 9 over 10. And let's do this really big over here again, just so we can see. We could have negative 3 over 5 all over 2 over 3. So we're going to multiply the top and bottom by 15. Because we're trying to find at least common multiple. So if I times the top by 15, I'm going to get 45 over 5 all over 30 over 3. And then this becomes 15, this becomes 10. Oh, that's not 15. This becomes 9, and this becomes 10. Right, so this is the same thing. We use the least common multiple to get rid of this denominator, but it's really much easier to just turn it into a multiplication problem. Alright, mixed number. So 4 times 2 equals 8. 8 plus 3 equals 11. That's our new numerator. Our denominator is the same. Divided by 4. So we could just times it by 1 over 4. And we get 11 over 16. Absolute value. So negative 21 over 7 is negative 3. Absolute value of that is just 3. And then I'll give you a problem here. Square root of 27 divided by 3. 27 divided by 3 is 9. So square root of 9, and then square root of 9 is 3. Alright, we're almost done. We have a few problems that we want you to try. So here's what I'm going to give you. Negative 20.3 divided by negative 14.8. So we're going to use our calculator. Same sign, so we know it's going to end up being positive. So I'm not going to even bother with the signs right here. 20.3 divided by 14.8. 1.372. 5/4 divided by negative 5 over 6. So we know it's different signs, so it's going to be negative. 5 over 4 times 6 over 5. Negative. We're going to cross cancel, and we're left with just negative 6 over 4, which reduces to negative 3 over 2. And then finally, we have this guy, which looks more complicated than it is. We have an absolute value sign and a division with a fraction. So we have negative 4 over 7. Instead of dividing by 3, we're going to multiply by 1 over 3, right? Because 3 is the same thing as 3 over 1, so the reciprocal would be 1 over 3. So negative 4 over 21. Remember, it's all in an absolute value sign, and that becomes positive 4 over 21. Okay, so is there a commutative and associative property of division? Right? So we had one for multiplication and addition. Let's see if division works. So So we have A over B equals B over A. Let's use the same numbers as before. 2 over 4 equals 4 over 2. So this equals 1/2. This equals 2. So no. And then we could try the associative property, but unsurprisingly, it's also no. Right? If I did 2, 4, 3, 2, 4, 3. So this would be 2 divided by 4 over 3 equals 1/2 divided by 3. So this is 2 times 3 over 4, which is 6 over 4. Oh, this is a bad example because it actually does end up working out. But it says there is no associative property division, so just don't try and do this. Bad example though. Alright, bring the pane. So now we're going to combine using variables x and dividing numbers to make it look more familiar. So here's the last problem. 8 plus x over 6. Okay, so we want to get this in something more familiar. So we're going to split this fraction. It's sort of like the opposite of adding fractions. So remember how to add fractions? So we have a vocab term, right? Add fractions. We need a common denominator. So if we have a common, right, if I have a over, let me write this. If I have, 4 over x plus t over x, I can write that as 4 plus t over x, right? I can combine it. So it's the same thing with here, but we're almost doing the reverse. So if I have a common denominator, I can actually split these. And this is the equivalent. This is the same thing. So once we split it, we can now reduce the fraction, and we get 2x minus 3. And this looks more familiar, right? Hint, this is the slope-intercept form vocab term. But sometimes you'll see something like this, and we sort of want to put it in something we're more familiar with, right? We want to get rid of a fraction, make it less ugly. And this is what we're allowed to do. So this one we have 2x over 3 plus 9 over 3. So this one we're actually going to pull out the coefficient, another vocab term. We're going to write it like 2/3 x plus 3. And then here we have 8 over 6 plus x over 6. So the reason why we're allowed to do this is because there's like a 1 right here, right? 8 plus x is the same thing as 8 plus 1x, but we're never going to write it like that because it's redundant. 1 times anything is itself, so we're just going to keep it like that. But we're going to break it up here just to make it more clear as to what we're doing. So this reduces to 4 over 3, and then we can just pull out the 1 over 6 to make it look more like a coefficient. This is our answer, but we want it in standard form, so we're going to put the term with the variable first. Right? Our standard form is always the highest degree first. So if I had something like x squared plus x cubed plus 3x, standard form would be x cubed plus x squared plus 3x. So we make the highest degree first and then go downwards. Alright, so that's it. Hopefully not too hard. You just got to be careful with your algebra and your signs.